Hello scholars, welcome back to the Kemet Maasai Academy. Today we're looking at solving algebraic equations with a little twist. This time the unknown quantity is in the index, in the power, in the exponent, right? So we're going to use the properties of the powers of the laws of indices to help us to solve these equations. Remember, if we're multiplying and the bases are the same, we add the powers, we add the indices. If we're dividing and the bases are the same, we subtract the indices. And remember, any number to a negative power is 1 over that number. Bear those in mind, and the other laws of indices might come to bear as well. So let's look. So what we're going to do then is we're going to try to rewrite the equations trying to get the same base. Since we know that when the bases are the same and we're multiplying, we can just add the indices. Or if one base is equal to another base, we can just make the indices equal to each other. That kind of thing. So we're going to try and get the same base. So we have 9 to the power of x is equal to 27. Can we rewrite 9 and 27 with the same base? In other words, can we rewrite them as a number to a power? Well, 9 can be written as 3 squared and 27 can be written as 3 to the third power. So in both cases, 3 would be the base. So we're going to rewrite the 9 as 3 squared, and we still have that x up there. Rewrite the 27 as 3 to the third power, 3 times 3 times 3. So now that we have the same base, we can just let the powers be equal to each other. So the bases are the same. Therefore, 2x is equal to 3. So x is equal to 3 over 2. So 9 to the 3 over 2, 9 to the 3 halves power is 27. And we can double check that. See? 9 to the 3 halves power. What does this mean when we're raising a number to a fractional power? It means what? The denominator is the root and the numerator is the power. So we're saying the square root of 9, which is 3, raised to the third power, that's 27. So that's how we know we're correct. Alright, so 16. Can we rewrite 16 and 128 having the same base? 16 is, we can write 16 with a base of 4. It's 4 squared. We can also write 16 with a base of 2. It's 2 to the fourth power. 2 times 2, 4, times 2, 8, times 2, 16. So we need to find out the 128. Can we write it with a base of 4 or with a base of 2? Because we need to have the same base. 4, 4, 16, 16, 4, 64. 64 times 4, way past this. So we can't write 128 with a base of 4. Can we write it with a base of 2 then? 2 2's 4, 4 2's 8, 8 2's 16, 16 2's 32, 32 2's 64, 64 2's 128. So that's 2 to the 7th power. So we write the 16 as 2 to the 4th power and the 128 as 2 to the 7th power, and we still have that x. So now that we have them with the same base of 2, we can pretty much ignore the bases and let the indices be equal to each other. So 4 is equal to 7x. So 4 over 7 is x. Right? X is 4 over 7. Alright, and we could always double check that just like we did for here. 128 to the 7th power. So the 7th root of 128, which is 2, raised to the 4th power is 16. So we'll get back our answer there. Alright, here we have This gives us a clue. This has a base of 5. That's a clue. So can we rewrite 125 with a base of 5 as 5 to a power? So 5 5's 25. 25 times 5 is 125. So we can write 125 as 5 to the third power. So this is 5 to the third power, and we bracket and put what was there already, equal 5 to the x plus 6. Now they have the same base, we can ignore the bases and let the powers be equal to each other. So expanding the bracket, 3x minus 3 is equal to x plus 6. Grouping the like terms, so 2x is equal to 9, x is 9 over 2. Okay? X is 9 over 2. Alright, here we have, and always look for the two numbers that are given. If you have a small number and it can be written, the big one can be written as that base, that's a clue to you that that's the base you should use. So can we write 81 as 3 to a power? 3 3's 9, 3 9's 27, 3 times 27 is 81. So 81 is 3 to the fourth power. So let's rewrite 81 as 3 to the fourth power, put our brackets and write back the index that was there already. And we have 3 to the p. So now they are both having 3 as a base. We're going to let the powers now be equal to each other. So 4p plus 4 8 is 32. Grouping the p's. So 3p is negative 32. P is negative 32 over 3. And we can leave it like that, or we can change it to a mixed number. Alright. Now, here we have 2 to the x power, 32 to the 2x minus 1 power. Alright, we can rewrite each of these as 2 to a power. So this is already 2 to the x. And it's bracketed, meaning we're multiplying these two. 32 is 2 to the 5th power. And we put in bracket the index. 128, we said 128 was 2 to the 7th power. So now they all have the same base of 2. So we're going to make the indices be equal to each other. And bear in mind, here we are multiplying the bases. Remember the laws of indices. When we're multiplying and the bases are the same, we add the indices. So it's going to be x plus 5 2's 10, 5 1's 5. We're adding them because the base is the same and we're multiplying here. So we add the indices. And we have a 7 here. So grouping the like terms, 11x is equal to 12. So x is 12 over 11. Alright, so we have 16 and 32. Those can be written with 2 as the base. 16 is 2 to the 4th power. And we write back the index we had already. 32 is 2 to the 5th power. And remember, 1 over anything is that thing to the negative 1. Right? So 1 over 2 to the 5th is 2 to the negative 5th. Alright, so we have 2 to the 8x, expanding this bracket, is equal to 2 to the negative 5. So now equating the powers, ignoring the bases, 8x is equal to negative 5. So x is negative 5 over 8. Alright, so we have 4 to go. Are you getting the hang of it? So we're trying to rewrite them with the same basis so we can use our laws of indices. Alright, so we have 3 as a base, and we know 27 is 3 to the 3rd power. So we have 3 to the 5x is equal to 1 over 3 to the 3rd power. And 1 over any number is that number to the negative 1. So 3 to the 5x is equal to 3 to the negative 3. 5x is equal to negative 3. X is negative 3 over 5. So we have a 4, an 8, and a 32. We know those can be written as 2 to a power. 4 is 2 squared. And we write back the y that was there. These two are being multiplied. Go back our brackets. 8 is 2 to the 3rd power. And we write back the index that was there. 32 is 2 to the 5th power. Alright, so we're multiplying here. That means we're supposed to add the indices. So that's 2y plus 3 is 9y plus 3 5 is 15 is equal to 2 to the 5th. Sorry, it's equal to 5 because we're equating the powers now. Alright, grouping our like terms, 2y plus 9y, that's 11y. 5 minus 15, that's negative 10. So y is negative 10 over 11. We have a base of 7. We know 49 can be written as 7 squared. 343, that's 7 to what power? 7 sevens 49, and 49 times 7. 49 times 7, 7 9 63, 7 4 is 28, plus 6, 34. Alright, so this is 7 to the 3rd power. Remember though, that 7 is 7 to the 1st power, don't forget that. So this is 7 to the 1st power times 7 squared. 49 is 7 squared, and 343 is 7 to the 3rd power. We are multiplying here. The brackets mean multiply. The bases are the same. We are going to add the indices. So that's 1 plus 2w is equal to 3. So 2w is equal to 3 minus 1, which is 2. So w is equal to 1. W is equal to 1. Okay. And it stands to reason because 2 1's 2, 1 plus 2 would give 3. So it stands to reason. Okay, so we're at the last one. Alright? The last one, number 10. So we have 1000 to the 2x minus 1 is equal to 10 to the 4th. We know that 1000 can be written as 10 to the 3rd power. And that's going to expand. 2 times x is 2x, 2 times 1 is 2, 10 to the 4x. So we expanded this bracket first, and then we're going to multiply it again by the index here. Alright, so 10 to the 3rd power. So we have 3 times 2x, that's 6x. 3 times negative 2, negative 6 is equal to 4x. 6x minus 4x is equal to 6. So x is 3. X is 3. Okay, very good. So we have solved our equations. The unknown quantity was in the power, in the index, the exponent. So the easy way to do it is to first reduce the numbers to the same base and then use the laws of indices, which tell us that if we're multiplying and the bases are the same, we just add the indices. If we have the same bases and they're equal to each other, we equate the indices. So using those principles, we have solved our problems. Alright, if you benefited from this video, just drop a line to say thank you, miss. in the comments. I really do appreciate when you say thank you. And I appreciate if you share the video with as many students as you can so everybody can benefit and lose their fear of maths and just embrace this wonderful subject. If you check our catalog and you don't see the video you're looking for, let me know in the comments and I'll certainly do that for you ASAP. If you have not subscribed to the channel Kemet Maasai Academy, you may do so now and click the notification bell so that you'll know as soon as a new video comes out, because you want to stay on top of things. You want to stay ahead of the class, stay ahead of your teacher even. Be on top of things. So my scholars, I'll see you in the next video. Take care.